This is AP Calculus 8.4, finding area between curves expressed as a function of x. When we say something is expressed as a function of x, that means y is by itself. So we might have y equals x squared plus 2x minus 6. Again, a function expressed as a function of x means y is by itself, or it's solved for y or f of x. So what we're going to do today is we're going to take two functions, and we will have a top function and a bottom function, and we will be given an interval from a to b, and our job is going to be to find the area in between those two curves within that interval. If you think about what we learned when we did integrals, remember we learned earlier that if we wanted to find the area under the curve f of x on the interval or the closed interval ab, then couldn't we take the definite integral of f of x from a to b, and that would give us the area underneath that red curve. So this integral would represent the red shaded area here. And then didn't we learn to find the area under the blue curve? We could basically do the same thing, take the integral from a to b of g of x dx. So the area of g of x, the area under the curve on the closed interval a to b, is signified by the integral from a to b of g of x dx. So the shaded blue area down here would be the area under the g of x curve. So if you are trying to find the area between those two curves, well then couldn't you just take the area of the entire f of x function and then subtract from it this g of x function? So the integral of the portion of the functions that is, or the portion of this graph that is between the f of x and g of x function would be what I've drawn in purple here, or shaded in purple. If we take the area of this entire thing under f of x and then take the area of just g of x and then subtract the area underneath g of x, wouldn't we have the area in between? That's just simple geometry, really, when you're talking about a shape like that. But we have to use integrals because we're given a closed interval and two different functions. We have to use integrals to actually find the area, because area of odd shapes have to be done with integrals. And so to find this area between the two curves, it would simply be the integral from a to b of the difference between the top function minus the bottom function. And remember, you have to have the d of x to signify the thickness of the little rectangles that we are supposedly drawing here. Okay, so that's the basics of how to find the area between two curves. So here's the first example that we're going to do. It says find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x equals 0, and x equals 1. So if we take all of these functions and we graph them in Desmos, we're going to get a region that we're graphing. So I'm going to do that first. I'm going to graph them in Desmos so that I can see what that looks like, and then I'm going to pull that graph over here so that we have the picture to look at to find the area between the two curves. So here is a picture of the region they're talking about. This red line is the y equals x squared plus 2. This one is y equals negative x. X equals 0 is the y-axis, and x equals 1 is this black line right here. So the region that we're talking about is this region right here. And if we're talking about the region bounded by these four lines, well, our a and b would go from 0 to 1, and our two functions, the top function f of x would be x squared plus 2, and the bottom function would be the negative x. So to find the area under this curve, it's going to be the integral from 0 to 1 of x squared plus 2, the top function, minus negative x, the bottom function, dx. And what we would need to do is just integrate this, then plug in the 1 and the 0, and we would have the area under that curve. And if I'm going to do this, the easiest thing to do would be to simplify it first. And once it's simplified, I will then integrate it. So here is the integral. I'm then going to plug in 1 and 0 to find the area between the two curves. And when I do that, the area between the two curves is 17/6. For the next one, it says find the area of the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals x. Now, you don't necessarily have to go to Desmos to graph these. You could graph them by hand if you want to. They're not any more difficult to do by hand, but I usually use Desmos just to give me a good quick idea of what the graph looks like, and then I could come back and draw it by hand if I wanted to, or just continue to look at Desmos. Sometimes on the AP exam they may ask you to graph it or show a picture. A lot of times though they might give you the picture. So there's no guarantee that you have to graph it yourself, but you should know that this one is a simple parabola. It's facing down, crosses the y-axis at 2. This is the y equals x line straight through the graph. So if you know a few things about this, about graphing, it's not too hard to do them by hand. I'll do this one by hand so that you can see how I would go about that. Okay, so I've drawn this by hand. This is my sorry attempt using the computer pencil. I'm not real good at that. But the red one is the f of x equals 2 minus x squared line, and the g of x equals x is in blue. And I want to point out one thing with this one. This is a good one to show you this with. A lot of times my students mess up something like this because they assume that they just want this thing, or that I just want this thing going from the y-axis to wherever it crosses the x-axis, and they forget to draw the left-hand side of this parabola. And if you do that, you won't be answering the question, because this just says to find the area of the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals x. It does not say and the line x equals 1 or x equals 0 and x equals 2 or anything like that. It doesn't give you any more specifics than this. So what you have to do is see where these two intersect each other, and where those two intersect are going to be your a's and b's, your x values at those points. So these two things intersect right here and right here. Okay, it's kind of hard for me to tell, because this is drawn by hand, where exactly this ordered pair is, because it looks like it's between 1 and 2 on my graph. This one looks like it's probably at -2, but all you have to do to figure that out is, if you think about it, aren't we trying to figure out where these two graphs are equal to each other? Where their x values are equal? So couldn't I just set them equal to each other and solve? And that'll give me my x coordinates of where they intersect. Okay, so that's kind of a common sense thing. But if you don't think about what you're finding here, you might not think to do that. So that's what I'm going to do, just to make sure I have the correct boundaries for my a and b. So if I do that, I'm going to set these two functions equal to each other. Then once they're equal to each other, I can factor it to solve. So I'm going to get everything on the right-hand side, set this thing equal to 0, and solve it. Okay, so looking at this, it looks like I should have had them crossing right at 1. So it looks like my graph is a little bit off. It probably should have looked a little more like this, where they're crossing at 1, 1. And if you do the math, if I plug 1 in there, it will be 1, 1. And we know that 1, 1 is here. If I plug in -2, that gives me a 2 minus 4, which is -2. So my a and b is going to be from -2 to 1. So if I want to find the area between these two curves, this shaded region is what I'm trying to find. So the integral, it goes from -2 to 1, and the top function minus the bottom function. The top function, understand, is the parabola, and the bottom function is your x. So 2 minus x squared minus x. I'm going to subtract those two, and then I'm going to integrate. So when I integrate, this is what I get. I'm going to then plug in the 1 and -2. Remember, you always plug the top number in first. So once I've integrated, I get 9/2. And if you are having trouble graphing and you don't like the way your graph looks, Desmos is always an option. I guess it wouldn't necessarily be an option on the AP test. If they give you a simple one like this, it's probably going to be non-calculator based. But again, if you just do XY charts like you did when you're in algebra, XY charts, figure out where they're going to intersect. As long as you know the basic shape of these, it doesn't have to be perfect. They're going to understand you're drawing it by hand. So you are not a computer, so that's okay. But that's the gist of it. The top function minus the bottom function, figure out where those two functions intersect to find your a and b, and you can find the area between two curves.